Okay, so just a couple of minutes on what's called the electromagnetic spectrum. It was the end of the last video, and I said there's the piece in the center here, this tiny little strip is actually the visible light. Okay? And we can expand it into its own spectrum, which you probably know as Roy G. Biv. And if you don't, then that's red, orange, yellow, green, blue, indigo, and violet. So the colors of the rainbow. Okay, make up a tiny little part of the whole electromagnetic spectrum. This is visible light. We tend to talk about all of it as being light. Really, it's electromagnetic radiation. It all travels at a rate of 2.9979 times 10 to the 8th meters per second. Okay, and because that's such a special speed, it's known as the speed limit of the universe. Nothing can go faster than it. And so instead of just calling it a V, we call it a C. Okay, so whenever you see C, it's the speed of light in a vacuum. In air, it goes a little bit slower than that, and then as it gets into more and more dense media, it goes slower and slower. Okay, but that's true for everything on this spectrum. So what else is on this spectrum? Well, right beside the violet is a type you've heard of before, ultraviolet. We can't see ultraviolet. If we could, it would be in the visible range. It has higher energy. This end is high energy. I hate it with my iPad. The camera just flipped around, so I just want to make sure it didn't flip in the middle of your movie. So this end is high energy and high frequency, and therefore short wavelength. And as you go down, it goes to low energy, low frequency, and long wavelength. So on the high energy side of the visible range is ultraviolet, just like on the high energy side of the audible range was ultrasonic. So this is ultraviolet. This is the ultraviolet rays or waves. This is the stuff that you buy sunblock to protect yourself against. The stuff that the ozone would normally block out if we didn't destroy the ozone. It has higher penetrating power than the visible. Visible strikes our skin, can burn our skin, but it doesn't penetrate beneath. Ultraviolet does, and that's what makes it so dangerous and why we wear sunblock. It's also the type of light they use in tanning beds. So maybe don't pay good money to buy sunblock and then good money for someone to expose you to the same light in a tanning bed. Okay, beside ultraviolet, next in line are X-rays, which I suspect you've also heard of. So ultraviolet can penetrate the skin and do damage underneath the skin. X-rays go even further. They go all the way until they hit something hard, like our bone. Okay, so really high energy. Whenever you go for an X-ray, they should give you a lead shield to put over the main part of your body, unless you're getting an X-ray of that piece. And they should give you that even if you're in a dentist office and getting an X-ray of your mouth. Lots of people think that shield is to protect our vital organs, which is true, but the main thing we're trying to protect are our reproductive organs. Okay, because that contains all of your offspring, and so you don't want to do any damage to your reproductive organs or the eggs if you're female that you're carrying. That'll be your potential children, right? Because the problem with radiation is that it can cause mutations, and then mutations become birth defects or cancer. Okay, so X-rays, high energy radiation. Getting one X-ray isn't going to expose you to so much radiation that you would be in trouble. But if you had an x-ray every day, or if you worked in the x-ray department, you'd have to be careful, because then you would be getting, potentially could be exposed to a lot of radiation. Next to x-rays are gamma rays. These are even higher energy. They're the stuff that's often given off in a nuclear reaction. It's what makes nuclear radioactivity dangerous. High energy X-rays, low energy gamma rays would be what we use when people go for radiation for cancer. And you might say, wait, didn't you just say this stuff can cause cancer? Yep, but it can also help us fight it. Just like too much of anything can be harmful. Can't survive without water, but you can drown in it. Okay, so it's not that radiation is deadly, it's just you need to be careful around it, just like anything else. Okay, and on the very end, at least for now until we break it up further, are cosmic rays. These would be higher energy than X-ray. They'd be what the astronauts are exposed to in outer space. Okay? On the opposite side of visible, on the lower energy end, right beside the red, is infrared. Lower energy. This is your remote control, what it gives off. It's not going to hurt you, doesn't even travel, doesn't penetrate. Even if you could do a little test. Can you turn the TV on if you hold one sheet of paper up in front of the remote control, 2 sheets? It doesn't have very big penetrating power. Okay, beside infrared, microwaves. And we talked about microwaves in the other video. Lower energy than visible light, and yet they're able to cook things in a microwave because they have the same frequency as that of water. Next to microwaves are radio waves, radio and TV. Okay, and then beside them would be long wave, like the ship-to-shore stuff. Long wave radio. In here would also be your cell phones. So low penetrating power, not a lot of danger to get deep into your organs, but can still cause cancer. Overexposure to any type of radiation can cause cancer and cause mutations in your cell. And when cell phones first came out, people thought that, in 10, 15 years, young people would have this spike in jaw cancer. Now, I know you're saying jaw cancer. Why? Because people actually used to talk on their cell phones then, all the time, like the way you text now. So now they're probably thinking it'll be thumb cancer. But just be conscious of where you put your phone when you carry it. Where do you put it? Is it, in your jacket pocket, in your purse? Is it in your front pocket, down by those reproductive organs that we try to protect? Okay, be careful where you put your phone, because if you carry it there every day, even though it's giving off low energy radiation, too much of anything can cause an issue. All right, we will come back to light tomorrow.